In this lecture series, we will discuss about the UART registers and UART's architecture. UART stands for Universal Asynchronous Receiver Transmitter. So we know for asynchronous system, we don't have a clock signal. We have to use the start bit and stop it. Now in this UART, we have been using for 16550 UART, commonly found in the 8086 systems, and this is accessed via the input-output pins. So it includes the registers like base address, typically COM1 and COM2, and registers offset from the base address. We have 0 into 0, 0x00, which is used for transmitter receiver to write to send or ready to read. And next is interrupt enable register, and other one is interrupt identification register or FIFO. Next one is line control register, and it is for the baud rate, parity, etc. And modem control registers also we have, and line status register for checking the transmitter or receiving the status. So we'll be using in and out instructions to read or write these input output ports. And next is to configure the UART. To communicate serially, we must set the baud rate first, and the baud rate should be maintained to fetch the output also. And we have to configure the data format, whether it is 8-bit data, no parity, or 1-bit, one stop, etc. And we have to go for the disable and enable of interrupts, that is optional for polling via the in or versus we can use the interrupt driven communication, and check the status before sending or receiving the data. So we have to set the baud rate, we have to configure the data type and which data type we are using here, and we have to enable and disable the interrupts if we need, and we have to check whether it is ready to send and receive the data. And next one is steps for configuration, and we have to set the baud rate, set the frame format. So we are setting the data format, configure the LCR for the data bit, stop bit, and parity, enabling FIFO, that is use FIFO control registers for buffering, and check the registers and use LSR to and ensure the transmitter is ready for the data is available. And key considerations for configuring the UART, that is Universal Asynchronous Receiver Transmitter. Yes, baud rate calculation is very important, because the device here it is nothing but the CPU clock frequency divided by 16 into baud rate. So whatever the baud rate, you have to multiply with the 16. For example, 1,15,200 Hertz clock and 9,600 baud, divisor is 12. We have to calculate the baud rate. And next, for polling versus interrupt, polling is nothing but simpler but the CPU intensive, and interrupt are the efficient, but efficient require OS support and ISR setup. Hardware access, direct input output port access in and out requires for root privileges on modern OS. And error handling, yes, it is also important, because we have to check for the errors before reading and writing. Modern systems, serial ports are less common, use LSB to serial adapters or emulators for testing. And this is the final architecture to finance, and it's a UART architecture, because UART is nothing but the universal asynchronous, and user comes under the synchronous, because we have the clock signal here. And in UART also you can see data bus transfer we have, and we have the modem control here. In data bus transfer, 8-bit data can be received and transmitter, and receiving and transmitting also we have a separate part here, like we have transmit buffer used for transmitting, and transmit control, which is indicates whether it is ready to send the signal, and it is ready to empty, and it is ready to clear the transmission. And next, for the receiver side also we have the receiving option, and indicate acknowledgement like receiving ready, and also receiving clear signal. And modem control, we have DSR, data selection and data transmission and clear signal. And from read or write, we have read option, write option, reset option, clock option, also the control selection, that is the signal selection. And you can see the data bus and read or write or modem are both by all are bidirectional. And whereas the transmitter and receiver, you can see it is in different types of arrow marks indicating the direction of the data flow. So we have discussed about the two types of architectures like UART and the UART. So once again, UART is nothing but universal asynchronous receiver and transmitter, and UART is nothing but the universal synchronous asynchronous receiver and transmitter, where UART is a asynchronous type where we have no clock signal. We have to use one stop bit and one stop bit, and in UART we have the clock signal here, and we don't need for go for the one bit like stop or start bit. And in the both UART and UART are both serial communication, and in serial communication we have three types of modes of communication, that is simplex, half duplex and full duplex. Simplex is nothing but device acts only as a transmitter, only as a receiver. When half duplex, a device can act as a transmitter or receiver but not at the same time. And in a full duplex, a device can act as both a transmitter and receiver but also at the same time. And compared to the architecture, UART and UART are very simple, and they can be configured with the key consideration of baud rate and baud rate calculation and setting of the data or frame format, and we are connecting with the proper input output ports. In next lecture, we will discuss about the interfacing of Bluetooth via the serial communications. Thank you.